Let's go ahead and continue here on number 2. So this is the toughest one of this section, so I just want to explain it again just to make sure everybody understands what's going on. So these are the two that need to be in parentheses, right? Because they're the ones that are going to help us complete the square, just like up here. So the constant, instead of going to the other side like it did in 7-1, just goes outside the parentheses. So that -8 just moved outside, and we worked with the x squared and x like we did for 7.1. So for number 2, I put the 15 outside. Notice I did not change its sign because this negative that I factored out of these two only goes with what's inside parentheses. It does not get distributed over here, so that 15 stays 15. Why did I take the negative out? Well, we learned it in the very first day of factoring in chapter 4. We never want a leading coefficient negative. We have to take it out as a -1 GCF. So when you divide this by -1, it turns to positive x squared. When you divide this by -1, it turns to positive 2x. So how you can check if you ever doubt yourself is do -x squared, yep, -2x, yep, positive 15. So as long as I can get my original problem back, I always know I'm on the right track. Okay? So -1 GCF taken out. Now we're ready to complete the square because completing the square was step number 1. Make the leading coefficient 1. And ours was not 1, it was -1. That's why we did that. Then we do half of b squared. So b is 2, so we do half of 2 squared. Well, half of 2 is 1, squared is 1, just like in the last problem. Okay, now here's where the second difference occurs. So first difference was you had to take out the leading coefficient. So whatever it is, in this case, -1, and then divide each of those terms by it. The second new thing is this is not really positive 1. It's inside parentheses. So this gets distributed here, here, and here. So this is really -1. So if I want to counteract it and do the opposite, I have to do positive 1 here. So this one's -1. Therefore, that one must be the opposite, positive 1. And remember why it needs to be the opposite. It needs to be the opposite because these two need to cancel so I can get the original problem back. And -1 plus 1 do cancel. I'm not going to cancel them because that defeats my purpose. I'm trying to put this in Vertex form. But just to check it, see if it goes back to the original. Okay, so let's do our fast little factoring here. So we have -1 in the front, which tells me my parabola is going to cut downward. And then in parentheses, we have square root of x squared x plus 1 quantity squared, because this is really x plus 1 times x plus 1, factors of 1 that add to 2. And then out here, I have plus 16. So is that in vertex form? Yes, it is. So that's our answer for that piece. So vertex form always has the x in parentheses with the squared and then the number outside. So now you should all be able to tell me what the vertex is. Opposite of what's in parentheses, comma, what's outside. So there's my vertex, -1, comma, the exact same thing that's outside. So -1, 16, so we have to add one number there. So there's the vertex. Axis of symmetry is always a vertical line, so it's x equals, and I just pull the x from the vertex. This parabola cups upside down, so because it cups upside down, the vertex is now the highest point. So this one's going to have a maximum value, and that maximum value is whatever the y is, 16. That means it's the highest y in the graph. There won't be another y higher than that. Find the x and y intercepts. So we'll start with the x-intercept. And remember, intercepts always make the other letter 0. And always write it down because that's going to help you with your point at the end. So go up to the original and make that f of x, that's your y, make that 0. So 0 equals negative x squared minus 2x plus 15. So there's two things you could do. We can't factor when there's a negative in front, so you could take a GCF out, or you could just move everything over to the other side. Let's do that. That's easier, I think. So when you move this x squared over to the left, it becomes positive x squared. When you move this negative 2x over to the left, it becomes positive 2x. And when you move this positive 15 over to the left, it becomes negative 15. So anytime you cross the equal sign, every sign changes. So now I just have my normal little problem. So factors of 15 that's subtracted 2 are 5 and 3, different, largest plus, and then just add them and make sure is 5 minus 3 positive 2? Yep. So x plus 5, x minus 3 equals 0. So if a times b equals 0, either a is 0 or b is 0. And this is going to give me my two x-intercepts. So negative 5, positive 3. X is negative 5, y is 0. Intercepts are always written as points. Don't ever write an intercept not in point form. And the other x-intercept is x is 3, x is 3, y is 0. So there they are. So these are the x-intercepts. Always points because they're the point where the graph crosses the x-axis. So negative 5, 0, and 3, 0. Let's go ahead and label our vertex and draw in our axis of symmetry. So our vertex is negative 116 up there. We drew in our two intercepts, negative 5, 0. Let's see if we can get up a little bit higher. Negative 5, 0, and 3, 0. So now we need our axis of symmetry. X equals negative 1, which remember is a vertical line. Arrows on both ends. So we are ready to go. We have 1, 2, 3 points, and we need 2 more. So let's find those last 2. And this is also a mother function, just like the last one, because the leading coefficient's 1. Well, negative 1 just tips it over. So I could actually go left 1, down 1, right 1, down 1, left 2, down 4, right 2, down 4, and get some more points if I wanted them. But first, let's answer the questions that they've asked. Then we can worry about trying to get everything in, and I can't, so I'm going to make this small again. So now we have y-intercept. Y-intercept means make x 0. So again, our Y-intercept is down here. So everywhere I see an X, I plug in 0. 0, 0, 0. So f of 0 equals negative 0 squared minus 2 times 0 plus 15. So that's 0, that's 0. So f of 0 is 15. So that means the y-intercept, x is always what's in parentheses, 0, and the answer is always the y. So we can go to our graph and graph 0. Yikes, I put an arrow there. Darn it. So over 1, down 1. So to do the mirror image, left 1, down 1. Or you could say this one's right 1, this one's left 1. And then if we wanted to do the other mother function points, we could go left 2, down 1, 2, 3, 4. Right 2, 1, 2, down 1, 2, 3, 4. And remember, when you graph those, they should be mirror images, 2 on the left, 2 on the right. And you don't have to do those additional points, but just know about them. If you're ever like, oh, wow, the teacher wants 7 points, you can always use the mother function as long as this is 1. 1, positive 1 cups up, negative 1 cups down, and then you just follow the mother function of 0, 0, 1, 1, 2, 4. Okay, the only thing we have left is domain and range, and like I said, that will be on your test, and we do need to draw the graph, so let's go ahead and do that now. So domain and range. So remember what I said on the last one? Every single vertical parabola has the same domain. And that's because this arrow tells me it goes left forever. This arrow tells me it goes right forever. So they'll eventually cover every x coordinate on the graph. So left forever, right forever, because domain are the x's. For the y's, remember I said it's easier to roll your pencil. So what's the lowest y? Woo, I'm running into arrows. So that means the lowest y is, since it's down here, negative infinity. And the highest y, that's why I always label the vertex, so I have that there, is 16, and it's an actual point, so I'll get a bracket. And remember, on interval notation, order matters. You cannot have these switched. You can't make this positive infinity. The smallest number is always listed first, the largest second. Smallest first, largest second. So be careful with that. That's why I always say left to right. The leftmost x value is negative infinity, rightmost x value is positive. And on range, you go bottom to top. So the lowest y value is negative infinity, the highest y value is 16. So that's another good one to study. I know I have one of each on your test, one that cups up and one that cups down. So now you have 3 different problems to study for those 2 10-pointers on your test. So again, that's like number 11 and 12, same as the other 2 before. And you can also use these 2 to help you with the practice test. The 3rd page of the practice test is 2 problems just like this. And that's why I added domain and range in, so you could use those as guides. Okay, I'm going to stop the video there, and we'll pick up on page 9 on the next one. See ya.